Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a second look at our typedefs_03, which focuses on a slightly more complicated and in-depth example of our typedef struct and typedef enum. This video is part of a larger series of videos focusing on the fundamentals of the C programming language and specifically some of the advantages of using structures. This video assumes that you have watched the earlier video on structures and specifically the earlier video associated with our typedefs_03, where we argued against using individual arguments and instead rely on a single variable that is a structure. And specifically, what we'd like to do is we'd like to leverage our get user properties parametric, where we simply collected the information about the user from the command line arguments. Now, you'll see after we get done with this example that whether you use the command line or the parametric version or the interactive version doesn't really matter. The focus of this part of the video is instead to look at how we can persistently store and retrieve information from a file. So we're actually going to do this example in somewhat of the reverse order. In other words, in order for us to be able to read the information from the file, we first need to figure out how to write the information to the file. So this assumes that you've already gotten a copy of our typedefs_03.c and have been able to successfully integrate it into your fundamentals driver. We want to take just a second to look at the typedef enum that has the unknown status, which remember maps to a equal to 0, an integer of 0, active equal to 1, and inactive equal to 2, as well as the structure that has some basic information about a user. And we know this structure as user properties. And so the idea here is that we want to be able to store some of that information in a file and then later on ultimately be able to retrieve it. So let's jump into our typedefs_03 and remember that it has its own switch triage as well as its own help function. And so what we want to do now is we want to piggyback off of one of our earlier examples. Specifically, we want to piggyback off of our get user properties parametric, at least initially. And the idea is that after displaying the user properties to the console, we ultimately want to be able to export it to a file. So let's come down here and take a look at our export function. And you'll notice that our export function accepts a file pointer, and it also accepts a user properties variable by value. The first thing that should jump out at you in this function is the fact that instead of passing a file name, we are actually passing a file pointer. This means that we are relying on somewhere else in the code to open the file and possibly even check for a valid file pointer. And instead, in this function, we are assuming that we are being given a file pointer, but we still want to check to make sure that it is currently open and, in this particular case, available for writing. Now, there's a couple of things to consider when using a function like this. Most notably is whether or not we want to write or append the file. But in this particular case, we essentially have no control over that inside this function. The only thing we can do is make sure that the file pointer is, in fact, not equal to null. At that point, then, what we want to do is we simply want to write to the file the different fields inside of our example structure. Now, the one thing to note here is this gives us a great opportunity then to leverage our return value. And so we have been rather naive or even cavalier in returning exit success everywhere. We would definitely want to improve on that, for instance, in our validation logic. But this gives us our first great opportunity to do something other than assume success. So the very first thing that we want to do is go ahead and create a integer return. And return value, or rather results. So if you want to use a shorter variable name, you can call it return underscore value or results. And what we can do is we can simply assign it the value of exit success and then simply return our results. Now, so far we haven't really done anything with logic here. So the first thing that we want to do is we want to check to make sure that our output file pointer is in fact not equal to null. So we say if output not equal to null, do something. Else, we have a problem. And what does that look like? Well, what we can do is we can provide a print statement, maybe an error, unable to write or access, we'll leave it generic here, access file, followed by new line. But more importantly, what we want to do is we want to say results equal to, and then in this case, exit failure. And so now we can return a result of failure if we did not have a valid file pointer. Now, under the do something part, we simply want to leverage an fprintf to write to the open output file pointer in whatever order we would like to write the example structure, and specifically in whichever format we would like to see it written in. I'm going to give you two different examples, and we're just going to comment one of them out. So the first one that I'm going to do is just simply going to allow for you to print it as a text file where each one of the values are on a separate row. And it might look something like this right here, where we have, for instance, the user ID, and then we follow it up with a colon and a space and a %s with a new line. And in this case, it's going to start looking a whole lot like our display function. And basically, each piece of information gets its own line. Not bad. You can spend a little bit of time lining the different fields up, and there's definitely nothing wrong with this format. Sometimes your user or your client may want you to do something like this. But what we're going to see in just a second is there is an alternative way to outputting this data that is perhaps a little more friendly for other applications and specifically for parsing things in the future. And so continuing on with this, we've got one last field that we want to provide, and that is simply our status. And so you remember from earlier, that is a %d for an integer. And in this case, then we simply print out the status. Now, a couple things to note here is we do not close the file. We are relying once again for that responsibility to be handled elsewhere. In this case, our whole goal is just to take that open output file pointer and write the contents to the file. And as I said, there's nothing wrong with this format, but what I'd like to do is I'd like for us to look at a slightly different format, and that is to separate the values by commas. And in this case, what we'll do is we'll do it ever so slightly differently, and we'll have output. You can do this in multiple lines if you'd like to, but what we'll do is we'll provide for the format spec 3% S's separated by commas and then a %D followed by a new line. And at this point, then, the only thing that you need to do is to take care to provide the fields in the same order as the format spec. So in this case, it's going to be example.userid, example.firstname, example.lastname, and example.status. Now, you can, if this gets a little too long, you can actually take a second to go ahead and break this up into multiple lines if you like the way this looks. Maybe this is a little bit easier to read, as well as you can also do this as multiple F statements, just like I did in the first example. And this is going to be the one that we're going to stick with, not only for this example, but also for future examples when we are working with CSV files. So at this point, let's go ahead and build it. Let's make sure that we don't have any mistakes. And we now have a working export function that we can test by simply adding it to our get user properties parametric. And so at this point, what we're going to do is we're going to piggyback this on the end of it, and we will pass then an open output file pointer. And what we're going to do now is we are going to pass the example. Now, this means that we have to go ahead and set up a open output file pointer. By the way, this is example 01. And to do that, we simply declare a output file pointer. And then once we have committed to collecting and writing the information to a file, we simply say output is equal to fopen, and we specify the name of the output file. Now, in this particular example, I'm just simply going to hard code that. In just a second, we will do something a little different here, and I'm going to also coincidentally have the name of the output file match the variable name. There is no reason to necessarily do that. But we also are going to choose to write the file, which means that it's going to overwrite any contents of the file. You can optionally also choose to append it. Either is fine. As a matter of fact, we can take a second to play around with this. And then the other thing, of course, that you want to do after you make the call to your export user is you want to go ahead and close your output file pointer. So I'm going to go ahead and set this code separate from our get user parametric in the display. I'm going to go ahead and build it real quick. And at this point, what we want to do then is we want to come back to our console. And we want to go ahead and run the parametric version of our typedefs_03. And at this point, you'll see that it produces this nice little table on the console. But more importantly, if you type in dir, you will see that there is now an example_01.csv. And if you're on a Windows machine, you can simply type in explore followed by a dot, which will open up the folder. And you can take this and you can drop it into NetBeans. And we can see that we have now successfully stored the information that we collected in our structure. We have now stored it to a file. So we've essentially accomplished half of what we want to in this video. Now our goal is to figure out how can we read that information back in. Well, essentially what we do is we once again go down here to our function, to our little helper function. We notice that it accepts an input file pointer. In other words, once again, the responsibility for checking to see if the file exists falls to us, but the actual opening of the file is done elsewhere. Okay, so you'll see why in the future why we would want to potentially do it this way. So essentially our fopen is going to be done elsewhere, and inside of this function we assume that we are being passed a file handle. Now, also note that we have our user properties is passed by reference. So I have a star in front of the example here. So in other words, it's a pointer to a user properties or the address of the user properties variable. Now, the idea here is I want to be able to read the file, or specifically, I'd like to read a line out of the file, depending on the format of the file. And I would like to essentially be able to push the information into our example structure. Essentially, what I want to do is I want to be able to update the example, much like what we did in both our get user properties parametric as well as our get user properties interactive. Note that in both of these examples right here, or both of these functions, I pass a example user properties by reference. So we're going to do the same down here, except now we're going to get the contents from an open file. So first thing we want to do is just like we did with the export, we want to go ahead and take a second to create a temporary variable, integer results. We want to assign the value of exit success to our results variable, and then we want to simply return the results. What we can do now is we can check to see whether that input file pointer is not equal to null. If it is, we can do something else. We have a problem. And once again, what does that look like? Well, at the very least, we say results equal to exit failure. And then we provide some sort of message to the user, error, failed to access file. And once again, you could refine this message a little bit. We won't necessarily know what file we are trying to access, but we can say, for instance, failed to access the input file. You can work on your message a little bit, but what we'd like to do now is we'd like to take a look at what we will do if, in fact, we have a valid file pointer. Now, we're going to be covering files in depth later on, so I'm only going to do a very quick example here utilizing our fscanf, and particularly what we want to do is focus on the fact that we have 4 columns in our CSV file, and we have a choice of how we want to read them in. Particularly what we can do is we can read them in as 3 strings, and then optionally a 4th string or an integer for this last column. So let's take a second to play around with this. So what we want to do is we want to combine the concept that we saw earlier with our scanf that allowed for us to directly update the structure using the address of the individual fields. So essentially what we did with our scanf, we can do with our fscanf. And at this point, what we can do is we can simply make a call to our fscanf, and we'll leverage the input file pointer. And what we want to do now is we want to think about what that format spec should look like. So we'll have a %s, comma, %s, comma, %s, and then a %d if we wish to directly read in the value as opposed to parsing it like we did in our parametric example, so where we converted a string to an integer. So in this case, what we're going to assume is that the format in the file is correct. And since we were the one that wrote it, hopefully it is. So at this point, then, what we can do is we can specify the address of the example, and particularly for that first %s, we are going to put that in the user ID field of our example. The second one is going to be populate rather our first name. The third %s is going to populate our last name. And then finally, the last one is going to populate our status. Now, as I mentioned earlier with the printf, you can also take a second to put this on multiple lines if you like the way this looks. Also note that this particular approach is fraught with potential errors, runtime errors, because it's making a lot of assumptions, most notably that the file format is correct. Once again, we'll handle that in a later video. At this point, then we can go ahead and build it. And what we'd like to do is we'd like to see if we can successfully import the data from the file that we just wrote. And so to do that, or to demonstrate that, what I'm going to do now is I'm actually going to create another user. So in this case, what I'm going to do is I'm going to have two users, a user properties example 01 and a user properties example 02. And what I want to do now is I want to read the contents of the file, or I want to open it first, and I'm going to read the contents of the file, and I want to put it in the example _01 user. I want to make some modifications to it, and then I want to export it as a different user. So let's see if we can make this happen. So we'll start here by adding a input file pointer. As I mentioned before, the ownership or the responsibility for opening and closing our files is going to fall outside of our function. So here what we'll do is we'll say our input is equal to fopen. And in this case, what we're going to do is we're going to open our example _01.csv that we wrote earlier. So this time we're going to open it for reading. Before you forget, you want to go ahead and close your input file. And what we want to do now is we want to see if our import user properties file works by passing to it the input file pointer. And also we want to pass to it the address of our example _01. Now, what we want to do is we want to display our user properties. That's where we're going to see if we've actually accomplished successfully importing it. And let's go ahead and build it again, and let's see if we can get this one to run. So once again, I'll clear my screen. I'm going to go ahead and check my switches. And you'll see that to import the user, I need to provide a file name. So what you can do is you can simply borrow from the help that I've provided. And in this case, we'll provide the typedefs _03 switch, import user properties file, and the name of the file. And you'll see that I have imported some of the information, but in the wrong format. Specifically, if you notice that the entire line ends up on the user ID, or ends up being placed in the user ID, and generally speaking, the rest of the fields are a mess. You can sort of guess why you are getting these values in the first thing by virtue of the length of the user ID. If you recall that from an earlier video when we were looking at structures, we know based on the memory address of the individual fields that essentially the fields lie next to each other in memory, And so essentially what is happening here is the user ID is essentially overriding the additional memory or the memory allocated to the other fields because that first line is longer than 10 characters and it does not contain an end of string until it gets to the one, or actually right after the one. So long story short, we will see this again when we start covering strings, but essentially what you're seeing is 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the 10th character is essentially being put into the position where the first name field should start. So long story short, we have a parsing issue. So if you come back to your code real quick and we go to our import user properties file, what we want to do is we want to play around a little bit with our format spec. And so basically this was a nice start. This approach does work when you are dealing with integer and double values, but it doesn't work so well when you're dealing with strings. And why is that? Well, because the %s looks for white space. And if you notice how we have written our file, basically we have no white space, and that was intentional. This CSV file format is very useful in the future because it allows for an easy delimiter. However, we need to be able to handle it differently than what we've tried to do because the %s, or rather the first %s, is going to look at this as one long string. So how do we accomplish that? Well, what we want to do is we want to take a quick look then at the scanf, and also remember the fscanf function behaves very similarly. And specifically, we want to take a look at this table of characters that we can use, some of which we have used already. There's our %s, but what we have not yet used is this % with a pair of square brackets. And what this does is this allows for us to specify not only a set of values that we should include to look for, but also when we use the caret symbol, we can specify a string of characters to ignore, or basically look for and then end our search. So let me just give you an example here. So instead of using our %s, what we'd like to do is we'd like to think about how we would search for the first field if we were required to do this by hand. And so essentially what we would do is we would accept any character except for a comma. And so what we do then is instead of a %s, we would simply specify any character except a comma, followed by a comma, and then once again, any character except a comma, followed by a comma. For the third field, it is once again going to be any character except a comma, followed by a comma. And these square brackets just allow for us to include a set of characters. So what I'd encourage you to do with this example is just play around with different file formats and see if you can successfully read in information using sets of characters and looking for just certain characters. But in this particular case, what we'd like to do is go ahead and build it, and we'll rerun it, and we'll see if we are successful in parsing our information. And sure enough, we are, because effectively the first %s stopped when it found a comma, the second %s stopped when it found a comma, and the third %s stopped when it found a comma. And then the integer wasn't really a problem because we read it in with our %d. Once again, we assigned all of these values directly to the fields in the structure using the address of the individual fields and the fscanf function. Now, let's see if we can make some sort of modification to our structure and then ultimately write it back out to the file system. So what we need to do is we need to go back up to our type defs underscore 03, and before we open the output file for writing, what we want to do is make some modification to our user. So in this case, what we want to do is we want to, for instance, change the status. So in this case, what I'm going to do is I'm going to make myself inactive instead of active. And now what I'm going to do is I'm going to export our user properties file. We are once again going to need a output file pointer, and we simply provide our example underscore 01. Now, if we were to do this, we would not have opened our output file, and we would expect an error or at least a message based on our function needing to check for a valid output file pointer. So the first thing that we want to do is say output equal to fopen. And in this case, what we want to do is we write our example 01 underscore 01. And in this case, we're going to call it modified.csv. And in this case, we can open it for writing or appending if you like. And then close our output. And at this point, then we'll go ahead and build it. We'll test it one more time. And now when I type in dir, I should see example underscore 01 underscore modified. And specifically, if you were to take a look at this file, we should now see that I am no longer active, but I am in fact inactive. We've got one last thing I'd like for us to do before we end this video. We'd like to utilize this second structure. I'd like to take just a second to, instead of modify the existing example 01, I'd like to point out that if we want to make a copy of our example 01, we simply copy each one of the fields. And so, for instance, since the first field, the ID is a string, we would simply use our string copy. And if we notice with the string copy, then the first argument is a reference to a string, and the second argument is a constant string. So what that means is that we specify the destination first, in other words, where we want to copy to first, and then the second one, or the second argument, is the source. So you probably already picked up on that when we were using our string copy earlier, but in this particular case, it's probably a little bit more confusing because we aren't simply using double quotes to specify what we want to copy in. So in this case, what we want to do is say example underscore 02 dot user ID. That is going to be our destination. And then for the source, we simply specify example underscore 01 dot user ID. We do the same thing now with example underscore 02 dot first name and example underscore 01 dot first name. And we can continue on with the last name. And then since the enum is essentially an integer, we don't have to go through any fancy mechanism to make that assignment. We can simply say example underscore 02 dot status is equal to example underscore O1 dot status. And at this point, we could open another output file. So in this case, we have an F open, and we will call this file example underscore O2 dot CSV. And maybe at this point, we would like to create a log file of all of our changes. So we will open that one for append, and we'll have an F close of our output file pointer. And now we simply export, not user one, but rather what we would do is export our example O2. So rather than exporting our example O1, we will export our example O2. And if you wanted to, you could simply call this, instead of example underscore O2.csv, you could simply just call this a log.csv. So at this point then, anytime we make a change to one of our users, in this case, we also want to pass the file pointer, and forgot the open file pointer. So 1 second here. All right, so once again, we've got to pass this open file pointer and the structure. And if we go ahead and run this one more time, you should see a log.csv. If you take just a second to go ahead and open up the log.csv, there is Gregory Myers there once. And if we rerun this a second time, you'll see that every time I run the application, I essentially register that I have updated this user. So once again, hopefully you found this video useful. Remember that the key things to note in this example are that we are once again passing around and leveraging a structure, not only for the purposes of exporting it, but also for importing it. And then notice in our export and import functions that we are leveraging not a file name, but rather a file pointer. Now, what you'll see in the future is that we will put these functions inside of a loop, which will then allow for us to read multiple user properties in, or write out multiple user properties. So essentially, we could have an array of structures and simply export all of them to the file system, or we could import an entire file of users into an array. So once again, hopefully you found this video useful. As always, if you have any questions or comments, don't hesitate to email me, and thank you for watching.